Hi everyone, we saw previously how to space out widgets by using spacer, inset and uniform inset. Those gave us a way to reorganize widgets and we were able to use them to build a window. In today's video we will add to that and learn how to space out widgets in a different way and also how to align them. This is done by just using flex parameters, an interesting topic. Here is how the flex tract looks like. It has these fields: axis, spacing, alignment, and WeightSum. This is taken from this page. You can find it in the description below. Let's go through these parameters one by one. The first one is axis, which we used many times in the previous videos. As you know, the values that this parameter can take are horizontal and vertical. The second one is spacing. These parameters tells Gio what to do with the leftover space and thus how to pack children. The values for this parameter are SpaceAround, SpaceBetween, SpaceEnd, SpaceEvenly, SpaceSides, and SpaceStart. I will not try to explain the effect for each one of them for sure, for it is easy to display a picture and explain. Even better, I will build a window with different sections. Each sections will display buttons with different spacing. The third parameter is alignment. This parameter defines how children are aligned on the cross axis. The values that this parameter can take are start, middle, and baseline. Same here, we will see an example that uses different values for this parameter to see the effect. The last parameter is WeightSum. It's specific for flexed only. I will also show you its usage through examples. We have a lot to cover, so stick around. Let's build the window and use all different values of spacing parameter to see the effect of each one. As usual, I will create a folder for the code of this video and copy the main.go from video 3 folder. I will open the main.go in video 5 folder. I will start by changing the title of the window to video 5. I would need the buttons, so I will uncomment the buttons declaration. This time we will build 6 flexed sections, one for each alignment parameter value. I will change this rigid to flexed. I will set the weight to 1. Actually, I will set the weight to 1 for all the flexed, to instruct Gio to split the window into 6 equal sections. I will set the space between the flexed to 10 instead of 20. Delete the commented line from the previous video. Under each flexed, I will add 4 buttons, and for this I'd need a flex. Let's add it here. Copy the rest from above. Change the axis to horizontal and add a return here. Add the first rigid, copy the rest from above, indent the label under this rigid and change it to a button. Delete the button text for now. I will pick its text shortly. Close the rigid. Add the spacing parameter to the flex, spacing, layout.SpaceAround. Picked the first in the list. Set the text of the button to SpaceAround. Duplicate the rigid 3 times. Close the flex. Delete the rest in this block of code from the previous video. Copy the flexed block. Change alignment to the second value in the list, which is SpaceBetween. Set the text for all the buttons to SpaceBetween. Duplicate the flexed block again. Change the alignment value to end and change the text of the button. Change the button's pointers. I will use 1 pointer for each flexed block. We'll do the same for the rest. to have one flexed for each alignment value. Add the missing button to the button declaration. Let's compile the code and run the application. We have only space at the top edge. Let's go back to the code and add space between the flexed. Copy the first spacer and paste it after each flexed. Run again. So now things are different. Let's go through every row to understand the difference. For SpaceAround, the space is distributed around each button. The space left and right for every button is equal, which makes the gap between the two buttons larger than the space between the first and the last button and the window edges respectively. For space between the first and last button touch the window edges, while the buttons in between are evenly spaced. For space end, the space is at the end, and the buttons are packed to the left. For SpaceEvenly, the buttons are evenly spaced with equal gaps between each button and the window's edges. That means the space before the first, between each, and after the last are all equal. For space sides, the space is placed on both sides of the group of buttons, centering them in the middle. For space start, the space is concentrated at the start, while the buttons are packed to the right. Of course, we can use what we saw previously to add space between the widgets. For example, as you see, we can set the spacing to space end or space start, then add more space between the buttons by using inset or uniform inset like shown now. If this has been helpful and beneficial for you, please hit like and or leave a quick comment so I know I am on the right track. And of course, subscribe if you're new to the channel and Gio is your thing. Let's deal now with the third parameter, which is alignment that has 4 values. To explain the alignment concept in Flex, I will follow the same way as what I did for spacing. I will build a window with 4 flexed. Each one except the last will have 2 buttons aligned differently. The last column will have 2 horizontal labels. I will explain why shortly. Let's create a folder 1, move all the files created to show spacing concept to the new folder 1, and create a new folder 2. Copy the code from 1 to 2 and open it. I will use rigid instead of flexed to have buttons with their natural sizes. Change the spacing parameter to alignment with value layout.end. Change the text of the button to end. I will be using 2 buttons only, so I am deleting the other buttons. To show the alignment at work, we need 1 button larger than the second, and then they will be aligned by picking different values for flexed alignment parameter. One way to change the size of the button is to change its max and min. As I explained in video 1, every Gio layout function receives a layout.context or GTX variable, which includes constraints that tell the widgets this is how much you can use at minimum and maximum in each direction. In another word, gtx.constraints.min is the minimum allowed width and height. gtx.constraints max is the maximum allowed width and height. Each of those has X and Y. So the button or any other widget can only size itself between those two limits. So if we set the same value to min and max, the button will take that size, not smaller and not larger. And this is what we're going to do. Let me write all what we need to set the size of the button, and then I will explain. gtx.constraints.max.x equal gtx.dp unit.dp 100. So you got the first part of the equal sign. The second part of the sign is gtx.dp unit.dp 100. This is converting 100 dp, which is density and dependent pixels, to actual pixels for the current display scale. So Gio here will now force the layout size to be exactly 100 by 100 dp, no matter what the content inside, like text, needs. Once this first rigid is done, let's duplicate it and overwrite the flexed form from the previous example. Change the alignment and the button's text to start. Change the button pointer to btn2 for this block. Do the same for alignment middle. Duplicate the rigid again. Change the alignment to baseline, and since this value is specifically used to align labels, the constraint setting is not needed. Changing the size of the label is within the material.label function. Change the buttons to labels. Set the size of the first label to 20. Change the second button to label and the size of the label to 60. We don't need the rest, so I will delete it. Let's compile the code and run the application. Need to delete the unused buttons. I used 3 blocks of buttons, so I will update the last block to use button 3 and delete the rest. Run the application now. The first row, alignment end, is used. The buttons are aligned to bottom. The second row, the alignment used is start. The buttons are aligned to top. The third row, the alignment used is middle. The buttons are aligned to middle or vertically centered. The last row, the alignment used for the labels is baseline. The text is aligned on baseline. The last flex parameter is WeightSum. It's specifically used for layout.Flex children. Gio looks at the sum of weights provided for all flexed when WeightSum is not used. When it's used, Gio will use it as a denominator instead. What does this mean and what are we talking about here? Let's go step by step and try to understand the first point first. We will have 2 flexed, each one has a button. We will build 2 cases which cover the first point. First case, weight equal 1 for both flexed. We already saw this at the beginning of this video when we did spacing. Second case, first flexed has a weight 1 and second flexed has weight 2. This is the theory. Let's go to the practice now. I will create a third folder to store the code of WeightSum cases. Let's start with case A. I will copy the code from video 2 since we don't need to build something complicated. We just need 2 flexed. Open the file in Visual Studio. I will take the 2 flexed and move them up under the flex. This is exactly what we need. Delete the rest. Fix the indent. Close the first rigid. Set the weight to 1 for both flexed. change the button text to 1 and 2, change the button pointer to button 1 and button 2, delete the extra buttons from the declaration, change the window title to Video for WeightSum. Let's compile and run the application. As expected, each button takes up half of the window. Go back to the code to implement case B. Change the weight of the second flex to 2. Run the application. Button 1 takes half of what button 2 takes. As if the window was divided to 3 units, button 1 took 1 unit and button 2 took 2 units. In another word, button 1 is actually taking 1/3 of the window and button 2 is taking 2/3. Let's go back to the theory and reconcile and conclude. The sum of the weight for case A is 2, so button 1 takes 1 divided by 2, or half, so each button takes the weight of its flex divided by sum of the weights. Let's apply for case B. Button 1 takes 1/3 and button 2 takes 2/3. Let's use WeightSum parameter now and see what is the effect. I will add WeightSum in the flex and set it to 5 and keep everything as is. Run the application. First thing to notice is that we have an empty space while we didn't have it when flexed is used. So how come now? Let's go back to the board. We have 2 flexed with weight 1 and 2 respectively. And since we're using WeightSum, Gio will use it as a denominator and button 1 will take 1/5 and button 2 will take 2/5 and the remaining 2/5 will be empty space. This is useful if we want proportion but don't want the children to always stretch to fill all available space. Before I finish the video, I will keep this picture up. You can take a screenshot. It summarizes all the values of spacing and alignment parameters. I'd really appreciate your thoughts in the comments. It helped me understand what's working and where I can improve this tutorial. If you're finding value in these videos, consider subscribing and sharing this channel with anyone coding in Go. Your support helps the Gio community and helps the channel grow and keeps me motivated to create more in-depth content. Thank you.